Hello and welcome back to the channel. Right, this is part 5 of our 4-channel DVM build. I have rushed ahead a bit and I've connected the 4 voltage dividers. They're a 5:1 ratio divider. I've also, on the first one, got an 18650 and a battery holder connected. And as you see, channel 1 is showing a voltage of 0.681 volts. This is obviously a fifth of what we really want. So what we will do is we'll just quickly go to code. Right, let's just find the window so you can see what I'm doing. I think it'll be that one. Okay, and what I will do is I will add so we've got channel 1 times the multiplier, but then we've got to times it by 5 for the voltage divider. So let's put a lot of that in brackets, probably too many brackets. We could minimize it a bit, but I ain't gonna worry. This is just so it'll calculate the channel 1 times multiplier first, and then times 5. I mean, that's going to be an approximation because obviously the voltage divider is going to inherently have a tolerance with the resistors, which we can work out later. We can add an offset. So let me just throw that sketch in and turn off the editing window. And hopefully if all goes well, it shows us the voltage of that cell. Right, it's at 3.405 volts. And it's fairly stable at the moment. Let's just wait for a bit. Yeah, I think it's flickering a bit. Okay, what I might do now is actually add a bit of stability to that. Actually, before the stability, why don't we, now we've got the dividers on, let's just open up a window here. We're actually running at this one here, which is 6.144 volts at the ADC. So the times 5 of that is horrendous. I only want 0 to 10. So 0 to 10, I can actually come down to here. We'll change the gain. We'll up the gain to times 2. It's that one there I want to enable. This will give us a better resolution, and it will, because of the dividers, it'll be basically 5 times that, so it's a tad over 10 volts, and 0 to 10 volts, and that will be ideal for what I want. One thing we've got to change is, let's just copy that, and that is our multiplier. Where's our multiplier? Here's our multiplier. So let's just paste in the multiplier there. Okay, and that should be all we need to do to up the gain. Let's blow that in and see what it does, and turn off the display. Okay, right, we've upped it now. We can see there is a bit of flicker there. It's going between 10 and 5. And now I think would be the ideal time. We'll add a bit of stability to that. What I'll do is we'll add some stability, and we put a stable channel on channel 2 temporarily, just so you can see how it works. Right, I found a nice little routine online. It's a library called Responsive Analog Read. It's primarily meant for the Arduino's analog input channels, but you can actually divert the values from, i.e. the ADC, through this. So we're going to give that a bash. Let's try and switch on the screen. Right, first let's just put the library in. So hash include, excuse me, I think it's one of those, responsive, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, log read dot h. I think, oh yeah, that's highlighted, so that looks like that could be good. Right, that's telling us we're going to include this library. We could do it anywhere in this section. Right, what we got? We need an extra variable. Actually, eventually we will need an extra 4. So I'm going to put an extra 4 there, and we'll add A's, and we call it ch1a, and they can be almost pseudo variables for the analog read. Right, now I've got to work out where we need to put this bit. I have got it written down on a piece of paper here. For once I'm almost prepared. Not. Right, let's have a look. Void loop. Let's put it up here, just in the void loop, because you want to run this every time. Responsive analog read space, and we need another variable. I'm going to call this analog as analog1. It's going to be channel 1s. Bracket, we need the pseudo, get that capital right, pseudo 1a, comma, whether we want it to go sleep, I'm going to say false, and the gain 0.1 to start with. Okay, and we also need to do analog 1 dot set analog resolution. Am I spell that right? Probably blooming not. 999. Don't quite understand that. The instructions said you should is to do with the ADC, how many bits it is. I've tried doing 16 bits and also 65536, which is 16 bits, which is the how many bits our ADC is. Neither seem to work, but 9999 seem to, which equates to the maximum reading of the count. So hopefully I've got that right. Nice highlighting. Let's just do a quick compile and see if we get any errors, because my spelling's never as good. Nope. Yeah. Set analog res shouldn't have an S. There you go. Okay, my spelling's not up to scratch, sorry about that. Okay, so far I was happy with that. Right, so we've set that. Right, so channel 1 still reading our ADC at the moment. Right, now we need to, so I'm looking through my paperwork. I'm sure I'm missing something here. Channel 1, 2. Okay, right, and let's have a look. See where I can put it here. This is where we actually call it now. So channel 1 equals bracket ch1 No, no, no. So I'm reading the wrong line. And totally forget what I've said there. Dot update. Right, this is actually calling the routine. I forgot the dot. Dot update, and we'll tell it it's ch1. So what it should do is it should take that ch1, throw it through the analog read routine, and it should come out on analog 1. Okay, so what we can do now, where's our display? That displays our channel. So we said we was going to do it on channel 2. Right, so channel 2. So it's going to be come through there. I think it's before the multiplier, isn't it? Yeah, it's before the multiplier. So instead of ch1 or 2, we now got to say, let me just locate it on my printed sheet. Where are you? There it is. It's analog 1 dot get value and 2 brackets. So hopefully, oops, got the get value. Right, so that should get the value from the analog 1. So basically, that's going to, this one here is going to be the raw ch1. This is going to be the dampened after it's gone through the analog read. I'm hoping, let's see if it compiles, and we can then have a look. Okay, it seems to have compiled. Let's turn off, see what we got. It hasn't done the times the multiplier, is it? It's still only got the okay, it's not doing the times the multiplier. Maybe I need to, let's add the multiplier in earlier, shall we? So we actually, right, so this section here we read the ADCs, and then I'm going to do ch1, I've got to capitals, ch1 1 crikey, equals ch1 times the multiplier. So if I just grab that, copy, paste. Okay, right, so we're automatically changing ch1 to the multiplier before we go through the responsive analog read. It also means we can then take it out of there. So we can, and then let's roll that again. Turn this display off so we can see it come in, hopefully. Right, it seems to have compiled, and is it still not good? 42. So we still have an issue there. Why have we got an issue? Okay, let's take that out because we don't need that, just in case. Oops, you didn't see that. I had left the multiplier in on line 2. I'm going to flick back and let's just see if that makes any difference. Probably won't make any difference at all, but we will try. Okay, that's interesting. It's, as you see, it's still showing that 0.681. Very strange. Okay, analog value. Okay, I will be back in a minute. I'm going to have a play and see what I buggered up there. Right, I'm back. Hopefully I have sussed it. Bit of operator error, and all it is that should be channel 1 times the multiplier, and then the whole lot times 5 for what do you call it, and then we take the 5 off that. Alright, now let's run it and see what we get. Okay, is it compiling? Yeah, it's compiling. Let's just flick over, see what we get. Okay, here we are. Right, now the top line is the raw value coming in, and channel 2 is the buffered value. Okay, it's still flickering a bit, so why don't we change the gain, see what we can do. I don't know which way to go here. Right, okay, again, let's go 0.01. Let's see, let's just compile that and see what that does for us, really. Okay, let's minimize that. Okay, it's definitely dampened it quite a bit. As you see, we're flicking from 0.5 to 10, and we're averaging about 0.8. So yeah, that's nicely dampened as well. Let me just move them in, unplug the battery, and just see what the response is like. Right, hopefully you can still hear me. Right, oh, they both went 0. Oops, plug in. Okay, I think that's a very acceptable response. The beauty about the responsive analog read is on rapid changes it accelerates, and it's as fast as the input, and as it gets to its point it slows down. So yeah, I'm quite happy with that. What we need to do now is make all 4 channels run through the responsive analog read. Right, let's do it then. Let's add all the 4 channels. Let's just pull up the screen so you can see it. Right, we're basically, this is going to be a copy and paste exercise, really. So we want channel 1, channel 2, channel 3, channel 4, channel 2, 3, 4. Okay, I should have actually started higher up. I think we added those at the beginning of the video, so we don't have to do those. We have to do obviously another 3 of these, so Control C, 2, 3, 4. Let's break them up so you can hopefully see them better. Okay, so these are going to be called analog 2, analog 3, and analog 4, and analog 2, 3, and yeah, analog 4. And obviously these relate to the pseudo variables 2, 3, 4. Okay, let's put the gain on each the same. What we got now? We've got 4 of those. We've got 4 of those. We need obviously 4 updates. Control C, 2, 3, 4, and this is analog 2, 3, 4. Relates to CH 2, 3, 4. Right. So this is actually channel 1, isn't it? So let's So I can actually probably Control C. Where did I go from there? V. So that's 1, that's 2, 2. Do I hit the right key? Oh, that looks good actually. Can't do that to the rest. That one there. One there. 3, 4. Okay, that should be. Let's just try and throw it in. That should be good for all. Okay, it seems to be good for all. Yep, right, that's gone in. Now channel 1's showing the actually a dampened reading, which is a lot more stable. Obviously channel 2, channel 3, channel 4 are not connected. And they're just showing 0 volts. What I may do is actually add a bit of code. Do I add a bit of code? No, that's not too bad, I suppose. Right, I could try. Let's just try and move the battery over and see, just to see, make sure the other analogs are working. Right, hopefully you can hear me. Let's just this plug that should be on the second one. Okay, that seems to work all right. Third one, that's not working. I've got the right one. Yes, I've got the right one. Okay, third one's not working. Just take these wires out. Is the fourth one working? It may be we need to do a bit of diagnosis. That's on channel 4. And that should be alright. Let's just check, make sure. Yeah, that's working. Okay, for some reason this board is not functioning. Just make sure everything's still connected. That's my hop's been pin. Okay, right, I'll look into that for a minute. Right, I'm going to look into that. What it looks like is one of our ADCs boards is either killed over or is connected wrong, or we're not addressing it correctly in code. So I will have a look and get back to you. Okay, and welcome back. Right, problem solved. It looks like it's a limitation of the library. It's only taking 2 variables, analog 1 and analog 2, or the first 2 that we defined. I do not know why. So I'm going to try something really crazy. And we're going to try and throw everything through the same variable. I don't know how successful this is going to be. Right, so should have deleted that. Why didn't delete? Thank you. Right, so we'll keep analog 1. So what we're going to do is basically load the variable, display it, load, display, load, display. Right, let's see what happens. Right, we've just got analog 1. This could be fun. We've got that. And what we need to do, that's what does the update. So I'm going to cut that lot out. So I'm going to do V there. Don't need those. So what we're going to do is load it with channel 1 and then get the value, which would be analog 1, display it. And then Control C, Control V will load the same variable again, channel 2, and display it. I have no idea if this is going to work, ladies and gentlemen. Let's do it again. I don't know if it will process this fast enough. Analog 1. And this is where I was just doing a bit of testing. Control C, this one's going to be hold on. Is that better? Yeah. Right, analog 1. So we're actually going to use less variables. I want channel 4. That's the only thing we can do is see if it works. If not, we may have to rethink using the averaging, which I don't really want to do, but let's see if this will compile in and whether it works or not. Right, I need to take that off. Has it worked? I do not know. I have a voltage on 3. Right, let me just go through them. Where is my voltage? Hopefully you can still hear me. Right, channel 1. Okay, that's good. Channel 2. That's good. Channel 3. That's good. Channel 4. That's good. The only thing, it does seem a bit not stabilized, which is a bit odd. Alright, let's have a mosey up here. I mean, that should be quite stable, shouldn't it? But it does actually seem to be working. What happens if we increase the gain? I'll just increase the gain to 0.001. Let's see if that has any difference. No, I think that's probably made it worse, isn't it? So, not really happy. Okay, I'm not really happy the way it's rolling at the moment. Did we... What I could do actually, let's add, because I know I can do 2 variables. Let's do 2 variables and alternate them, because then that should halve the time, shouldn't it? 2A falls to 2A. That's okay, that's okay. So we can say, alright, that's analog 1. Let's do analog 2, gets the second value. Analog 1 gets the 3rd value. Analog 2 gets the 4th value. Let's see if that has any impact on it at all. Oh, sorry, I didn't put the screen up so you could see what I was doing. Right, there. Can't even see if that compiled or not. Did it or did it not? we'll try it again. Sorry about that, ladies and gentlemen. Okay, it didn't make any difference. I'm actually using 2 variables now. I don't know why it is I can't use 3. I will look in a bit more in this. It looks a bit more unstable. I will come back to you. Okay, well, welcome back. Well, I didn't resolve the issue. It does look like the library could take a maximum of 2 variables at a time. Anything more than that, and it would just spew out what you put in and didn't do anything at all. So I've actually reverted right back. I mean, this does quite often happen in good old development. I've taken the library out, removed the extra variables, the CH1A to 4A, and it's just very basic now. It just reads the values, we do the multipliers times 5 and basically display them. And this is let's just switch off that display. I'll show you what we got in a moment. That's channel 1. Right, channel 2, channel 3, and channel 4. I mean, what you will notice, hopefully you can hear me, is this is flickering. It's a 5 resolution, and that looks like that probably comes from, if I go up to here, we have a resolution on this of 1 millivolt, but we also, you got to remember, we're going via times 5, so it'll have a resolution of 5 millivolts. So that's just flickering up and down. Let's just turn that off. That's just flickering up and down, basically 1 point. To be honest, I've probably got too many decimal points, so what we can do is we could actually reduce this decimal point, couldn't we? So we have something like, it'd be 3.4 or something volts. I mean, that would probably be more logical. And what I'm going to do in the interim is anything which reads 0 or below, I'm going to just add a bit of more text and just have the over range symbol. Right, let's get back to our code, and we could actually do that directly in this section here. Well, I did do this the other day, so it's on paper somewhere, so this should go without a hitch. Famous last words, I know. I've got to find it first. Here we go. Right, we just do an if. We'll just do channel 1 to start off with. If CH1, oops, no, I need to open bracket. Open bracket if CH1 is less than 0, close bracket, because we don't want to go minus. We ain't worried about reading minuses, or do we leave it? Let's just see what this comes up with. If it's less than 0, we want to, let's copy, hold on. Let's just see what it does, shall we? Nope, Control Z. Control C. V. Let's give me some space. So if CH1 is less than 0, then we need to do the brackets, because that tells us we want to do this, and we will do I'm going to do text URG. under range, close brackets, and obviously it's not 3 decimal points this time. 28, that could be okay. Right. Else, so if it's under 0, we display under range. Else, or basically anything which is above 0. Else, we want to basically do what we normally do. Is that right? Try and compile it, shall we? See how we get on. Oh dear, what have I done? If was not, it's an if statement. But a capital if, no. It's because I put a capital I. Oh. Why is Android case sensitive? Pain in the rear end. Okay, it's happy with that. I don't know what it's given me. Let's turn off the display. It's giving us nothing because we're actually on 0 at the moment. I don't think I'm going to actually use this. Less than 0.1. Don't think I'm going to use this. I may do, may not. Let's see what that gives us. Let's switch that. Okay, that gives us the under range. Well, yes, it's actually quite nice, isn't it? Just flicking up a bit. Okay, yeah, I quite like that. Let's put on our display. Let's do that to the rest of the channel, shall we? So basically that's going to be very similar. So Control C, V. If channel 2 is less than that, and then we print underage at position 20. Else, we do what we normally do. Right, Control V. If channel 3 is less than 0.1, then we're putting under range at position 12. Else, we display normally. Right, last one. If channel 4 is less than 0.1, we'll display under range at position 4. Else, we do what we normally do. And compile that in, see what we get. Let's come down here. Hopefully we'll get a lot of... Right, it's still floating up a bit on a few. And we got 3.4. And that, right. Should we take off the decimal points? Right. What's the easiest way of taking off decimal points? Right. Right, on this I think the easiest way would probably be to do it in this section here. So could we divide everything by 10? Let's try, shall we? Divided by 10. Let's just run that. That's the first one. I don't know if this is going to work, ladies and gentlemen. I will put this back to here. So I've only done it at channel 1. It's just showing under range at the moment. Let's plug in channel 1. Okay, yes, it is showing it. Right, I think I know what we can do here then. because I think what we can do is change. Oops, let me put the display up so you can see what I'm doing. I think we could probably change that there. Change that to 2. See what happens. I am playing. I have no idea what the outcome will be here. Right, come on. Okay, yeah, that looks good. It's given me 3.41. I've got 2 decimal places, which is good. What I will do now, I'm going to move that to 29. Compile. Let's flick back over. Will that shuffle it all over one? No, it didn't. Why didn't it? Or did I have to go the other way? Did I need to go to 27? Yeah, I need to go 20. Need to go back on myself. Sorry. It's -1, not +1, because I've already got characters on +1. Let's try that. That still hasn't moved it. Why hasn't it moved it? Sorry, I wasn't showing you. It was a bit of an idiot error. I was actually changing this bit, which is the under range. I need to change this to 27, I think. Right, now let's compile and then go back to here. Right, yeah, that's perfect. That's put it exactly where I want it. Now all I need to do is basically, let's do the same to everything, shall we? Right. Put it in brackets, that works that out first. Divide it by 10. Let's do all of these. Bracket. 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 Wow, my phone's going mad. I'll have to look at that in a minute. But let's get this out. Right, that's all channels divided by 10. Now what we need to do is all channels, I need to change to decimal point number 2, and then all get the right ones. So that would be 1 less. So that would be 19. 19. There it is. It'd be 11. And 3. Hopefully, ladies and gentlemen, this is correct now. Let's update throw the sketch in. Let's turn this off and see what we get. Okay. Right, we got 3.41. Quite happy with that. Next channel. 3.4, 3.41. Happy with that. 3.41, happy with that. 3.41, right, that's very good. At the moment I ain't going to worry too much about the averaging. It's not too bad at the moment, and this is really going to conclude episode 5. Episode 6, I'm going to find some probably sensors or something, and we'll do a bit more maths in the coding. So we can relate, like the voltages from sensors into the proper readings. Okay, many thanks for watching. Hope you enjoyed part number 5, and don't forget to subscribe.